Let's learn how to find the logarithm of these numbers using indices and standard form. Remember to keep your logarithm table beside you because we'll be using it. Solution. So the first question, A, we have 4.3. Now the first step is to express this 4.3 in standard form, that is in the form A times 10 raised to the power of n, where A is a number between 1 and 10 and n here is an integer. 4.3 is already a number between 1 and 10, so this expressed in standard form is going to give us 4.3 times 10 raised to the power of 0, because 10 raised to the power of 0 is 1 and 1 times 4.3 will give us back 4.3. Now here we express 4.3 in terms of 10 raised to the power of a particular value, which brings us to our logarithm table. In your logarithm table, it is drawn like this. You have x here. You have values ranging from 0, 1 to 9. Then you have this place labeled as difference. And you have numbering from 1 to 9 also at this side. And the values here, you have 10 to 99. Basically, what this logarithm table is going to give us, for any value you are looking for, let's say you want to find the logarithm of 50, let's say 50 is here. That means you are looking for a number so that when you have 10 raised to the power of that number, it's going to give us 50. Here that we have here, which is the same thing as 5.0, 5.0. Because all numbers there, though they are written as 10 to 99, they are basically numbers between 1 and 9.9. That is, all the values you are having are logarithm of numbers between 1 to 9.9. And from this 10, you'll be having 0, 0, 0, 0. Why? Because logarithm of 1, which is written as logarithm to base 10 of 10 raised to the power of 0, and gives us 0, which is the value we have here. But in this case, we are looking for 4.3, which we just go down to 43. That's how you see it in the logarithm table. And under 0, you'll be having 6335. Under 1, you'll be having 6345. Now here, we have just 4.3, which is the same thing as having 4.300. That is 43 under 0, difference 0. And when you come back here, 43 under 0 is basically 6335. But you don't have any difference 0, which is the same as 0. So we just have 0.6335. So for 4.3, 10 raised to the power of 0.6335 would give us 4.3, then times 1. And here we have 10 raised to the power of 0.6335. Therefore, our logarithm for 4.3 equals just the power 0.6335. Now the next question, B, we have 43.1. Now here also we express 43.1 in standard form first, which is going to give us 4.31 times 10 raised to the power of 1. And 4.31 we express as 10 raised to the power of a particular value. Going back to our logarithm table, what we are going to check is 43 under 1. Then this is the same as 4.310, difference 0, but we don't have any difference 0, so we only be concerned with 43 under 1. So 43 under 1 here is going to give us 6345. That is 10 raised to the power of 0.6345 would give us 4.31, then times 10 raised to the power of 1. Applying the multiplication law of indices, we just add up the powers. That is, we have 10 raised to the power of 0.6345 plus 1. And this gives us 10 raised to the power of 1.6345. Therefore, the logarithm for 43.1 equals the power we have here, 1.6345. 45. The third question, we have 43,100. Now, same thing here, we express this in standard form, which gives us 4.31 times 10 raised to the power of 4. And 4.31 can be expressed as 10 raised to the power of 0.6345 times 10 raised to the power of 4. We apply the multiplication law of indices here by adding up the powers. We have 10 raised to the power of 0.6345 plus 4. And that gives us 10 raised to the power of 4.6345. So therefore, logarithm of 43,100 equals 4.6345. And that's how to find the logarithm of the numbers using indices and standard form. Thank you.